Today, we are going to talk about Java sorting finally explained, comparable versus comparator, made simple. Comparable versus comparator in Java. So what that does is it compares and sorts objects. And we're going to talk about a natural order versus a custom order. We will also talk about collections.sort method, and then we will also talk about the collections, TreeSet, PriorityQueue, and TreeMap is not a collection, but we'll talk about it as well. Why do you need comparisons? Java can sort primitives automatically. However, objects need comparison rules. We define how objects are ordered. How do we do this? We have two different kinds of interfaces. We have the comparable interface and the comparator interface. The comparable interface defines the natural sorting order. It implements the compare to method, and the class itself implements comparable. So the comparable interface is used within the class itself. There are many classes in Java that use the comparable interface. And then what they mean by natural sorting order is basically how we as humans would sort things. It's intuitive, it's inherent to the class. Comparator interface, on the other hand, uses external comparison logic. It's outside of the class. It'll become more apparent when we run the code. The method it uses is the compare method, not compare to, just compare. And it just compares two objects based on some rules written in the overridden compare method. And this allows multiple sorting strategies. And the reason it does that is because here's the thing. Comparable is inherent to the class itself. It's implemented by the class. So there's only one compare to method. But you can create multiple comparator classes, multiple classes that implement the comparator interface, which is why multiple sorted strategies are possible. So let's compare the compare to method and the compare method. They're the same. They're the same. The only thing that's different is the compare to method is the method that's inherited from the comparable interface. The compare method is inherited from the comparator interface. And these methods, they both return a number. They return an integer that represents order. If the number it returns is negative, then that means that A comes before B. If it's positive, A comes after B. If it's zero, then A and B are considered equal in sorting. And here is a nice little table just to illustrate that point. Natural order. I alluded to this already. So natural ordering is defined within the class, and it's used automatically by sorting structures. It's the default way that humans would sort the object. Let's look at some examples. So strings, as we know, are sorted alphabetically. Integers are sorted numerically from the lowest value to the highest value. Dates are sorted chronologically from earliest to latest. And students are sorted by student IDs, some kind of identifier. So when sorting collections, there are numbers of methods we can use. So the collections class has a static method called sort, which takes in a list and sorts it. It can also take in as a second argument a comparator, but we're going to see that soon. There's a list.sort method that also takes in a comparator. And these can work with comparable or comparator, but you're just going to have to see it for yourselves when we run the code. So the sorted collections, if you recall from the collections talk that I gave a while ago, which is literally a few days ago, or maybe even just yesterday, TreeSet is a sorted set. TreeMap is a sorted map. The keys are sorted. PriorityQueue, it's kind of sorted. The highest priority element always comes first. That's what PriorityQueue means. For more details, please refer to my talks on collections. So again, the key differences: comparable versus comparator. Comparable is inside the class. And since it's inside the class, there's only one compare to method, which means one ordering. And it follows the natural order. Comparator is outside the class. It's outside the class because you can create many classes that implement comparator and implement multiple ways to sort collections and compare objects. It uses the compare method and it implements a custom order, so you can implement the method with your own custom logic. And here's an interview tip for you. Use comparable when a natural order exists. So basically, if you want to use the class, use comparable. But if you want alternate ways of sorting, use comparator. All right. Looks like it's time to code. Okay, fellas, we are back in our IDE. So as usual, we have some coding examples to go through. And the first one is going to be sorting students using the collection.sort method with a comparable that's implemented by the class itself. So the key thing is it's the class itself. So you have to use a comparable. Let's go to the student class and I'll show you what I mean. Okay, so let's look at the student class. So this student class, it implements comparable. So comparable, it's a parameterized interface that you can implement. And here you override the compare to method. So we're overriding the compare to method and writing our own custom logic. This is really nice because it's actually using the wrapper class to just compare, two IDs. So it's sorting the students by the ID. But the way we were actually taught to write this is something like this. So here, so here, you're comparing the first ID to the second ID. And if the number is negative, then this will come first. If the number is positive, this will come first. But let's go back to how things were. All right, so let's go to our runner class, and we will run the first example. So what we're doing here, we have an array list of students. We're going to add 3 students, and we're going to sort these students based on their IDs. So this means that Anna's going to come first, then John, then Mike. Am I right? We'll see. All right. So Anna's first, followed by John, followed by Mike. All right. Next exercise. So next exercise is we're going to sort students using a comparator. So we use this collections.sort method, but this time we're passing in a comparator. This is called the student GPA comparator. And it's called the student GPA comparator because we use descriptive variable names when we code, right? So obviously it's going to compare the students by GPA. But let's go into this comparator. So this is how you write a comparator, right? Okay, you have a class, it implements comparator, and you override the compare method. And you're taking in 2 objects. The 2 objects are the ones you want to compare. So we're comparing by GPA. So we're going to get the GPA of student 1, get the GPA of student 2, and then, we're actually using this double wrapper class to compare the 2. So that's how you write a comparator. And the nice thing about comparator is remember how you can have many instances of comparison? So you can compare by other attributes. Like you can write an ID comparator. Let's see what other attributes does the student have. You can write a name comparator. Well, that being said, let's go back to our exercise. So we'll run this. So it's going to sort by GPA. So since it's sorted by GPA, it's going to be John, Mike, and then Anna. Am I right? Who knows? Who knows? Yes. So yeah, so it's sorted in ascending order by GPA. We can stretch this box a little more. Okay. So let's comment this out. We will move to the next exercise. So this one, it's we're still using a comparator, but this is a lambda expression that we wrote on the fly. Yeah, I mean, we kind of use that term on the fly because instead of writing an actual comparator, we're just writing a lambda expression. So this is a lambda expression, and it's the same logic. Notice, you seen this line before. It's the same logic as this line right here. But let's run it, and you'll see for yourselves. So the result should be the same. So yeah, so this is lambda style. So yeah, it's still sorted by GPA, this one as well. Yeah, I also ran this. So this is a lambda expression as well, but using the collections.sort method. So we passed in the list of students and we passed in a comparator, which is the exact same one we're using here. All right. Now we're going to play around with sorted sets. So we have a tree set. And remember, any data structure backed by a tree is sorted. So we have a set. Sets don't take any duplicates. So what we're going to do is this tree set is going to be sorted using the comparable that the class itself is implemented. So it's going to sort by ID. So let's uncomment this out. Okay, we'll uncomment this out, run this, save it. Okay. So again, we're sorting by ID. 1, 2, 3. All right, let's comment this back out. Next, we're going to work with a tree set. But this time we're using a lambda expression and we're using a comparator. We're using a comparator, but it's in the form of a lambda expression, and we're comparing the names. So it's going to sort by name. So it's going to be Anna, John, and then Mike. So let's comment this out, and then we'll run it. Okay. So we sorted by name. So Anna, John, and Mike sorted in alphabetical order. Okay. Now we're gonna do let's see. Okay, yeah, we're doing TreeMap. So TreeMap is a map where the keys are sorted. So we're gonna compare the names. So let's go ahead and run this. All right. So Anna, John, Mike. So these keys are sorted. And notice that a key can be any data type as long as it's a reference type. It just can't be a primitive. Okay. So now we're gonna work with the priority queue. So like I already said, priority queue is kind of sorted, but kind of not. The job of the priority queue is to move the highest priority element to the front of the queue. So what's happening here is we're adding 3 elements. We're adding Mike, Anna, and John, and we're sorting by GPA. So what's going to happen is that the person with the lowest GPA is going to get popped off first. So even though he's being inserted, last is going to get popped off first, and then Mike will get popped off, and then Anna will get popped off. So let's see. And then this is just going to iterate through until the queue is empty. So it's just going to pop off the queue. And if you recall the poll method, what it does is it removes the element at the head of the queue. So pop that off, return it, pop off the other element, return it, pop that one off, return it, do that until it's empty. So that's how this loop is working. So let's run this and see. Crap, I never saved these things. Okay, let's go. All right. So looks like John got popped off, then Mike, and then Anna, just like I said. So anyway, this is all I have for you. I hope you learned something here. Until next time, have a good night.